Well, that was an announcement. Okay. Good. Well, thank you. I'm going to kick off the afternoon session here. I'm Mark Johnson, faculty member here at Clemson, director of the Center for Advanced Manufacturing as well. First of all, I want to thank you all of the speakers this morning. My job this afternoon is actually to introduce some of the speakers, but I was also asked to give a little overview of the Center for Advanced Manufacturing, to connect this to what we're doing here today about artificial intelligence. So I said, well, I'm actually a material science. I'm a physicist by training, so I'm not an artificial intelligence person, but I have given some talks at places, and I'm literally stealing from Lee Farah, who is with Applied Minds, who gave a talk at an IEEE meeting that I really liked last year. And it was basically, he did this on a chalkboard. But basically it starts out like this. It says, over time, you've got capabilities. And as humans, we're increasing our capabilities all the time over time. We're learning as a society, we're moving forward, time's advancing. This is the history of humanity. But we look at information technology, how that winds up interacting. We're at this point where computers and communication, whether it's artificial intelligence or going back to mechanical computers in the age of Babbage, years ago, we're having increasing computational complexity. And you have a lot of futurists out there that are talking about what happens when things wind up hitting that crossover point. Does suddenly humans start going down? They all lose their jobs. It's full of science fiction and all that sort of stuff. So the academic world is full of, writing papers and selling books. Or are we right before that crossover point? Or are we just beyond that crossover point? Are we, let's call it the singularity, whatever you want to do on that. And the question is, where are we as humanity? And this entire presumption of that is we're at that point where basically computers have greater capacity than human beings. And even in intellectual capacity, we may be there. But I think really where we're located is we're still back here. We're a long way. Human creativity is the thing that we have where we can wind up pushing forward humanity by working with computation much more than not. So this gets to, we're an educational institution. What should we be doing in terms of that? And I was talking earlier to a reporter. Is that reporter still here? Is that a reporter back there? Anyway, a reporter I was talking to that said, asked the question, what about when the robots are going to get your jobs? And my favorite quote on this is, for those of you who know him, Dr. Lonnie Love, who likes to say, if you're worried about robots taking all the jobs, you should study robots, right? And go into the field of robotics. So that's exactly what we're looking at. So similarly, if you're a company and you're worried about artificial intelligence disrupting your market, which is basically taking your jobs or changing your business, now's the time when you really need to be learning about artificial intelligence, working with it, because either you're going to do it or your competitors are going to do it. So how do we wind up moving forward together? How do we, as an academic community, work together with businesses to make sure that the companies in our community wind up moving together more effectively? So that's my entire, let's be happy about this outlook. And I actually honestly believe that that's the direction we're going at this point. We have great potential. So having said that, what's the Center for Advanced Manufacturing all about? And I'm sorry I don't have a little, I can't see the monitor here. So really, let's start out with what is advanced manufacturing. I get asked this question, especially in academic communities, but even more so in the manufacturing community. And I'd like to say this, and this is my question earlier for our colleague from Amazon who was here. The official federal definition of advanced manufacturing, which unfortunately I was on the committee that helped write that, uses the words advanced and manufacturing in the definition. Mrs. Stevenson taught me in 3rd grade, you are not supposed to ever do that. So I'm actually embarrassed that that's what a committee wound up with. So at the end of the day, manufacturing, you can do all kinds of services. You can wrap all kinds of information around it. You gotta be making something tangible. You're delivering something. That's the hard thing. What's advanced manufacturing? Why do we care about it here in South Carolina? That's the area where we're bringing technology to give you differentiated capability. Makes you more competitive. You got a bunch of ways you can compete as a business. You can compete by being the lowest cost labor, right? And certainly places like Bangladesh, Malaysia are places that are driving that direction. You can look at and say you're going to be the place that's going to extract the most resources from your area. And you've got a number of places where there are mineral wars going on around this world because they're trying to extract the most from there. Or you can say, We have the best education system in the world. We have the best national lab and scientific system in the world. Let's leverage these. Let's connect them together with the business community so that we can wind up actually moving further faster. And that's really the goal here. I have about 10 slides behind this, but I'm just going to voice track through this relative instead of just trying to click through things. When you take that perspective on things, you really have 4 things you have to work for. First, you need to be advancing that technology. We call that research and development. That's heart of the research mission at Clemson University, right? You have to be advancing the talent in partnership with it. And I say not just education, it's actually advancing the overall talent. That is actually the commodity of the future, which is to say the people that are able to act on these things, whether they go through and get an undergraduate degree, whether you're coming out of high school, whether you're 20 years out of school and you need to go back and learn how to program. And I also joke that I'm really good at, if you need to hire either a COBOL or a Fortran programmer, I'm good at that. But I have no idea, I'm not a good programmer today, right? I'm a great example of that. I need to go back and go to code camp myself. So that's 2 parts of it. Third part really is the engagement part. And engaging both with the industry is the outreach on it. But then you meet industry where they are and you suddenly recognize there's this whole idea of a supply chain. There are 5 times as many jobs and economic activity created outside of the company than there is inside the company. So you go to an automotive manufacturer here, you have 5 times more jobs in their supply chain, all spread up and down I-85. And this is beyond the boundaries of just one state. Let me repeat that for people from the State Economic Development Group. Guess what? Companies that work in Georgia and work in North Carolina, economic jobs here depend on it and having that connection together. And in fact, if you wind up looking beyond that, you take the I-85 corridor, those 5 states, from basically the Virginia Tidewater down to the Gulf of Mexico, 38 million people, $1.9 trillion economy. It's the 8th largest economy in the world. We should be working together to make sure we're setting the agenda of how technology innovation should be happening, not just here in South Carolina, not just across the Southeast US. We should be setting the model for how this winds up working across the entire nation, right? Because we can do that, and that's the kind of leadership we wind up doing. Now, just as important, there's the 4th issue, as well as the supply chain. You're looking at having your innovation ecosystem. How do you make sure that the technologies that are being developed here, by the students here, by the 3 or 4, computer scientists over here at BMW that, what do the kids these days call it? What's my side gig? They're doing coding at night because they want to do a startup company. I'm not just saying for BMW, I'm saying any places like that, right? How do you make it so that those people that are taking those innovations and pushing it forward see their best and brightest future in our community as well? And so building that resource fund. So that's what CAM is all about. How do we wind up bringing together, because the university has 20, 30 centers. I can introduce you to a number of researchers here. Ask what the topic is and I'll find people that are working on that are working on things, everything from artificial intelligence and robotics down to developing new fibers and new fiber materials that wind up going into advanced composite materials, whether it's looking at advanced chemicals and materials, whether it's looking at new aviation systems, whether it's looking at things for the energy grid. We've got all of those things. How do we work together as a community so we can get further, faster in supporting that manufacturing mission across the board? Because at the end of the day, as we're developing technologies, when it winds up getting up to that point where you're making something, you're delivering something, and someone says, I like that, that's ultimately where this economic value trickles back into the entire society as a result. So with that, I'm done with my little talk on that. You're welcome to get the slides afterwards if you want, and go from there. So it is my pleasure in the afternoon here, though, taking it to the next step and inviting Bob Grabowski back up. Bob, as you know from this morning, really artificial intelligence expert in this area. I think one of the most interesting things that Bob worked on, he shared a lot of slides with me at one point on this. And the experience where he was working on the whole DARPA Grand Challenge for MITRE was phenomenal. What was neat about it is just how many times they failed and how many different ways you could fail and crash cars as a result of trying to connect things together. The point was, every time you did that, you learned. You go off-road and you try and figure out how do you have sensors that go off-road And every time you go through a ditch, suddenly that sensor just is seeing the sand in front of you, and it's dumb at that point, doesn't know what it's doing. Good learning to have on that. How do you keep going back at it, building that in, building that collective knowledge? I think that's part of what we're doing here today. So with that, Bob, I'll turn it over to you.
Thank you, Mark. I appreciate how you pointed out our experience with failure.
It was good learning experience.
Yes. Get the mouse back. So keeping with my earlier promise, I'm not going to provide any solutions, just more characterization of problems. So in the earlier talk, I talked about artificial intelligence more from sort of the classification of the technologies from a technology perspective. One of the things that I really appreciated working for my previous job at the ARM Institute was that there really is sort of a push and a pull. There's the challenges that you have of how you push technology up, advanced technology, to be able to use more in industry. And on the pull side, what is the kind of things that industry really is looking for, and how does it have to tailor to those? Because in the end, you need the two coming together. And the purpose of that was to sort of address one of the things, which is the innovation gap, is I have a lot of early TRL that I build up to a certain point, but it isn't ready for production. You have the risk mitigation on the top side. From the production side, is that I can't really afford the risk of adopting some of these. How do you blend those two? So in keeping with that, what I wanted to do is just to set some of the context from the industry side, is the recognition that with respect to automation, and remember my caveat that I just call AI, just robots without wheels, and sort of you'll see automation, AI, autonomy all blending together, but we really are sort of at that, either at the poise of or having started the automation revolution, and we're seeing the point where autonomous systems, intelligent systems are no longer the ends. We build them because they're cool and we want to see a robot or we want to see AI, but as a means, which means now it's I'm using it because it works and I don't care so much about what it does, but how much that affects it. But the other is recognizing that when you talk about AI in industry or you talk about automation in industry itself is not a monolithic animal. The approaches that you provide for a large manufacturer in one particular domain are going to be different than what you apply for small manufacturers. And as you see, the way I look at it is that the underlying principles, AI, autonomy, are like DNA, but if you flip those bits a little bit, you grow different animals completely, and you have to recognize sort of those subtleties and bring the two together. And sort of sticking in with, as I said, not just AI, but augmented reality and all the tool set that you do. How do you get those to where they're actually producing some interesting product? So the rest of the briefing is going to be a lot of really cool movies. What I want to do is characterize some of those, and we're going to have a little bit of extra time at the end for questions. So the first question is always, so where do you get your taxonomy? I'm from that sort of classical culture. It says, well, why don't you make one up yourself? But over time, I've learned that it's always better to go to a source and say, people have really been looking into this. What are the different industries? What are the potentials? So you'll see with Industry 4.0, you see with sort of the whole AI automation revolution, people have been doing this for a couple of years, and it is kind of a hot topic right now. So what I chose is, rather than make up my own, I'm going to use this sort of as a basis set. And what this plot really shows, I like it, as you know, because it has colors in it. I like the colors. But it really kind of shows sort of the potential in where automation might be applied, where the early things are in terms of cost effectiveness. But this one was nice because it kind of broke out and showed some of those opportunities. We're just going to use this as a basis set to say I didn't make up my own set of things. So what I'd like to do is kind of step them through that, starting from sort of the biggest impact down to the different ones, which really in the aggregate might still actually be a greater impact than these. we start with sort of the aerospace defense side of things. So we'll go through the movies in a second, but really the kind of challenges you're talking businesses and manufacturers that are really high value assets, but relatively low production volume. They have a lot of time to get it through. Quality is important. High complexity in a lot of the aerospace and defense side. Every part has to be tracked through. The characteristics of the parts have to be tracked, sometimes beyond production. So you end up with layers and layers of V&D on top of that. And as you can see, just from some of the videos, you're talking companies that go all the way from grinding their own parts, putting them together in a large, complex system. And as you can see from some of the center ones, you're talking about taking panels from the side of aircraft that might have tens of thousands of holes that all have to be precisely aligned. There has to be verification that they're put in there. It has to meet a certain tolerance for drag. But the cost of these and what it does for the industry is so high, they can afford all of those extra layers. And the applications, now you're going to see it's hard to take pictures of AI, so you'll see mostly robots, but you know there's underlying AI underneath each of these. But you're talking about, how do I get machines that don't damage the asset as you're moving across? How do I track that inventory across the entire process? How do I add layers of V&V in there? And how can I reduce the number of how many eyes and how many people I have to put on that? But because the asset itself is so expensive and the industry is so expensive, you can afford all of those people and all of that process. Now, having said that, a lot of these manufacturers have requests that actually outweigh or far exceed their capacity. So how do they start meeting those? They can't produce planes fast enough, or they can't produce missiles at the rates at which we use up missiles. For all of these, so it isn't just robots to replace jobs. How do I augment to meet the growing demand of the high-tech things that I have in industry? And again, we see robot arms and stuff moving around, but it's more than that. Where is the AI that allows the robot to hold some sort of visual inspection that characterizes the airplane so that it matches it up with the model? So I didn't have to put 5 guys in there that rubbed their hands on it because they had 15 years of experience to understand how well that wing was broken down into tolerances. So again, the first one is really the aerospace side. There's a lot, aerospace and defense, a lot of potential for applications. In terms of opportunities, you're talking, how do I really get into the testing and V&D side? How do I get into the tracking of the parts? And again, through the manufacturing process and beyond. How do I account for the tolerances in the process? But because the investments are so large, money's not the same object, but how do I piece all those complex parts together? And that's one of the major places that AI can come in, is one from the perception side, the other from the data mining side. The next domain, sort of orthogonal domain, is the automotive, characterized really by high volume production, lots of scale variations in the sense that I've got heavy bodies that got to be welded together, all the way down to the electronics that have to go through each of the parts, down to the painting. It's really building a full system end to end, but in large production values, but that production can't be stopped because in order to meet the quota that you're going through, you have to sort of have a well-oiled machine. And we heard BMW talk earlier, they don't even control inventory. It's basically parts come in, they go back out the same day. You're not building warehouses. How do you manage sort of that high end? With respect to automation systems, a lot of them, they mentioned the robots that basically weld the body together. Those are robots moving out in open space. You can kind of program them. There's a lot of overhead in getting it set up, but once you do, you just start cranking it out and it runs full time. The other problem that you run into with automation and this automation mix is these are big things moving at relatively pretty good rate to get those through, and then there's people interleaved with them everywhere. So how do you manage such complexity with such volume with the people still in the space? So there's a lot of opportunities for how to deconflict that. And then the last one they talked about is specifically BMW being right around the corner. They can customize each of the cars. So now you're not just producing one sort of Henry Ford single vehicle going out. Every one of those are customizable in some point, which raises concerns of B&D. But really, automotive and aerospace already represent two orthogonal sets. The next one is the electronic industry. These are, again, high volume, but now you're talking about high mix components. Big plastic pieces, LCD screens, and then a lot of little parts that have to be put together. And even more importantly, now you're shoving them into really tight spaces, and you're doing a lot of manipulation of small components. So you can see a little bit more on the robotic arm side that how do I get those and put them in very accurate places. We can kind of engineer the environment a lot so that it's still somewhat linear, but as we get more and more advanced, they're actually going to have to move into tighter spaces, be able to handle small and large components, so you're starting to get into sort of the mix between robots and automation touching things, but also manipulating at a small point, but also back to the same thing with the automotive, large volume. But now your cost per unit volume is almost lower than the whole system that you have setting it up. The next field the next sort of domain is now in the food processing business. Now you're talking about, again, high volume, really basically inexpensive parts with lots of throughput, but you can't damage the pieces and parts that you're doing. You have to be able to manipulate them. Now you're working with possibly perishable things, so you have a timing problem. They have to be in sometimes controlled environments. So if you notice, there's some, the fishing industry up in Massachusetts is really facing a problem. People don't like to cut fish in 30-degree weather all day. Their hands get stiff. You start to run into problems, but the fish has to be kept at a certain temperature. And they're having such a labor problem that they're actually taking the raw fish, sending it overseas to be cut into pieces, sending it back to do the packaging in the U.S. So a lot of these get into that sort of, it isn't, we're replacing jobs, we just can't meet capacity with the jobs that we have. Now, some of the solutions here is rather than take something really stiff and put a big brain behind it, you can do things like change the properties of the compliant manipulation, and maybe, to steal a phrase, distribute the intelligence. In this case, it isn't digital intelligence, but it distribute that capability across the entire set. So you can see these robots with soft hands that can pick up things without crushing them, and they can form around that. How do you now build a system that can model that compliance and conformance in order to get the process you want? And what happens if today I want to make loaves of bread, but tomorrow I want to make cupcakes? So hidden in these, and we'll come back to that, is the reconfiguration time, and how much do I understand it, and how much of the product am I going to lose if I notice something, and how am I going to be able to monitor that? So a lot of that starts stretching into the big data problem and the modeling side. So the next big field, trying to keep with that orthogonality, isn't really manufacturing, but it's support for manufacturing. It's the distribution space. So we saw some videos earlier, and I believe we have it in one of these, which is the Amazon Robotics, the Kiva. How do I bring in large amounts of product, redistribute them, store them either for a short-term or long-term, package them back up to go back out, to be able to support sort of the infrastructure of all the other manufacturers that are going on. Now you have an inventory problem, you have a mixing problem, you have humans, how do you get there? Where's your validation, your verification and validation of your product and your tracking? And these are the kind of things that are really conducive to higher orders of AI. I would make the contention that something like Kiva Robotics would not have even been possible without being able to manage it at something at a much higher scale of complexity. So most of this is really about the high volume throughput. Now, most of these distributors are bringing things in and sending them out, so you sort of a more liveliness aspect. If you walk over to DoD logistics, they could have products come in that need to be stored for 6 hours or 60 years. So then you start to run into some real sort of logistics and scaling. Some of the interesting ones on here, and you see I've tried to interweave a little bit of the perception aspects of it and inferring some of the AI aspects of it, but you start to see some really clever groups like in China with robots that are moving around at a high floor level and actually going into the vertical dimension for storage. The next one that's really interesting in the sense as being a domain, you see it cuts across, is I wanted to put machining. This is industries where you're getting in a product and rather than be additive, it's subtractive. You're grinding on it, you're pulling paint, you're chipping, you're welding. You see that a lot in shipboard applications. You see that a lot in people were building the parts that go out to build roads. And the reason why this gets interesting is, as I mentioned with places like BMW and aerospace, you can pretty much build a robot through first principles that it needs to move through open space and it may hold something with weight, but it essentially isn't interacting as much with the environment. Once you start grinding on something or welding, you now have to account for the surface effects. If anyone's ever tried to sort of grind something with a hand sander, if you touch it just wrong, it's ended up putting grooves all over what you want to do. That ends up being sort of product problems. And you know that if you catch it just right or just wrong, it's going to cause real problems. So you really got to build up higher order models. And that gets a little bit more into sort of the predictive sides of artificial intelligence and how do I learn those models rather than try to do those off from first principles. And you can see that that goes all the way from simple companies that just cut holes in the side of pipes. The middle one, which is really interesting, is a robot that does additive, but it's actually building a metal sculpture. And you can see just from the grinding, I think we have one on here where it's, I think it was on the previous one, I'm sorry. But I thought the one that was really interesting is robots that are actually doing the welding of all the intermediate parts of ships. Continuing on that vein, one of the industries that's been the hardest nugget to crack in terms of automation is the textile industry. It's an industry that generates a large lot of volume, but you're working with really pliable material. It's somewhat fragile in the sense that when it snags on stuff, pieces of it come apart. It includes things like sewing, putting hems in, putting zippers on, and just like with the grinding, understanding how you're affecting the different compliance of those materials, you can see if you were building AI applications for a textile component, it's much different than building them for aerospace, even though you might be using sort of the same underlying principles. What's going to happen is some of the weighting of the things that are going to cause you problems poke up differently for this particular domain. If anybody has any questions, just let me know. We'll just kind of walk through these. And then the last one, so I'll be really early on this, is sort of, I wanted to capture the small manufacturer. So this is a repeat of all the previous ones we talked about, but now you're talking about localized companies, smaller companies that are really trying to compete, but they don't have the overhead in order to start up, and they don't have, the cost of shifting really challenges them. But at the same time, in order to stay in the market and compete with the larger ones, they're much more likely to adopt a disruptive technology. So you kind of have that balance between those. Can I invest in something new to stay viable, and can I afford it and have it not fight me out? So you can see that those companies go all the way from making cupcakes to doing local bread packaging that spread out, but they share the same kind of risks and risk matrices for how they would adopt that and what that means to them. And that's all I have. Is there any questions? So again, this was just kind of to set the context to say that industry is not the same industry everywhere. It's not, we're going to develop AI for industry and it works everywhere, go out and solve that. So if you're on the academic side, keep in mind that you want to get close to the user to understand their problems, because all you're going to do is adjust the weights in what you're doing. On the industry side, recognize the solutions that you hear for one thing are going to be different. And if you couple it with the earlier talk about the different fields of AI, You start to get into a trade space, and now you have that, this is the last part of that, now you have a language to start talking about what technologies would I use and where, and how might they apply. Any questions?
Oh, I was asking a question. It's interesting you said the textile industry is so resistant to automation, where that's on the sort of the sewing and finishing side, but the textile industry is sort of the foundation of automation, for lack of a better term. 150 years
Yes.
ago, some of the looms and things like that.
I think
Why? I mean,
not
we're-
resistant, textile isn't resistant, I think the margins of cost effect, what do you get by adding automation don't balance against the cost and the training that it takes for people just to do the sewing. And the difficulty of doing the sewing makes it so that the robots, or the automation isn't so great that it displaces the quality of workers. But you're right, the massive number of workers, what they're doing repetitively over and over again, somewhat limits that industry. So, I'm not going to get into the balance of does it take jobs or build jobs, and we had talked about this earlier, because so maybe I can bring that up. It really is a little bit of we will always adapt to the new technologies and find new ways to make it work that sort of could enhance, what we do. In the interim, there's going to be some disruption to that, but I also believe that I don't think the loom was so disruptive that it caused the decline of American workers the same way I don't think the telephone did. At the time, people thought it did. So, again, I don't want to diverge too much into are robots going to take your jobs? Is automation going to displace? I think it's going to re-characterize the entire environment.
I can add a comment to this discussion. One of the challenges in the textile part. So I was recently working with a person who is back in Stanford. And have you seen movies called the Jurassic Park, the Hulk, and all that, right?
Yes.
So this is the person who does the computer simulation. All the blasting and all that thing, he does. And since you can do the simulation, you can reproduce it, right? So, and he got a lot of awards now. He's an AI guy. And then he came up with cloths, right? Textile cloths. And he showed one of his finest work. None of this in the audience will look at it and say, this is envious, like really gross, doesn't flow, very stacked. This is the guy who got awards in, in all those beautiful movies. The problem is very simple. You can start simulating and generate the data for the things which we never experienced, like the muscle movement of dinosaurs and all that, because reality is here. The reality is somewhere here, but he's showing a simulation which is here, right? In the textile industry, the reality is much above than anything you can simulate at this moment. So due to that, since there is no simulation, it's very hard to even reproduce and define models. And of course, this is a very lucrative industry because everyone wears a cloth, and we all want a personalized dress, right? So it's really.
But you also have, this is where AI has a different domain of the problem, has huge impact. Right? You look at the number of companies, Crocker, and then there's companies that are coming up with all kinds of different clothes that fit you. It is custom bespoke clothes, and then they send you a survey in 5 minutes, and you get it. It feels like you say, "Oh, it's a little tighter on my collar, it's a little bit tighter on the middle," and then your digital model you adapts. And the next time you order something, it fits better. The next time it fits the end result.
Yeah, but the adoption becomes.
That's good. That's a good thing.
Yeah, it's a good thing, but once you don't like it, you see, everyone will want to look like a model before they buy, right? Once it doesn't, you don't look like a model. It's so simple, right? You rather go to the conventional models so that you go and get things done. So it's a very complex problem of fluidity. So it's really a problem of fluidity and how you model it correctly.
So to continue that, because it sort of is something we talked about over lunch, but I had mentioned maybe what is one of the gaps that's missing is we're talking about textiles with simulation, projection, working with somebody, and then after the fact they interact. What might be missing is the AI that determines what it thinks you should have needs to interact with something that knows you, and that's the personal AI we were talking about. If that personal AI already knows things don't fit here, things don't fit here, but I don't want to share that with everyone, and I don't want to build, clothes to the masses and then, try to tailor it to you. Maybe that's one of those places where you start to get into, as we're called, partitioned AI. AI that's personal to you, but it shares with this, and now you have AI talking to AI, and that might be the kind of things that are missing in the, how are we going to get to the textile? Because you're right, I buy something, and if after the fact I get to spend time on a survey, I'm not very happy about that. I want it there when I get it, but the interface, which right now is visual, as opposed to how does it interact with you, is insufficient. So one of the things that speaks to from the research side is, where's that missing piece and where's that gap? And again, sort of from me, which is I'm a perspective person, right? What perspective is required to make everyone's actions reasonable and rational would be, we're missing some component. And we're missing that component that the AI represents the person, because the AI that interacts with the people from the company is a company AI, not a personal AI.
Who's bought it?
But also parameters, in terms of parameters, a couple of weeks ago I was in a meeting in California, it's a day-night conference where there's about 20 of the AI people were there, and they were all talking about women's clothes. So there was no men's clothes at all.
No, the example I was going to use, I'll use now. My wife has some service for women's undergarments.
And
That
then-
she loves, she says, it's better and better and better and better
And
and
they
better.
are developing number of parameters was also out of 30 parameters. In that weeks, I learned so much about women's clothes, hemline, this line. I mean, you name it, I didn't know all of that. I mean, so much variables are there just to do the personalized part.
Right.
So we are not even there to
Right.
define what the personalized part is. And the number of variables are keeping increasing. So it's really a trend which is happening, but we are not there.
And that's one of the things we were talking about is how do you get to where you increase the observability of a system so that it can be more effective? Because most of the AI algorithms you're talking about are kind of doing blind assessments based on large volumes of people, which means you can't really do the level of. So you need something observable, which you can't instrument everybody and then make it owned by Walmart. So it's a really interesting comment. But maybe what you would capture out of that for the other, the people, the younger kids would be like, what can I build as the intermediate part that provides that capability so I'm not making a super singular intelligent system in order to predict everybody right down to the instances, but have some sort of interaction. Yeah.
Thank you, Bob. We'll move on to the next speaker. Rules here. Next time also, so it's not just me always asking it, we're going to ask one question from this table and one question from this table. So think hard about it, and especially the students and postdocs will wind up getting asked the question.
So, clearly people are not afraid of asking stupid questions, so that's okay. No such thing. So, our next speaker here is going to talk about accelerated learning in reality, plus augmented reality, hands-free smart glasses, and HoloLens. These are folks from Seagate. So we have Philip Riddle and Noel Bailina.
Everybody hear me okay? Okay, we shifting gears now. I'm the token industry guy, okay? So I come from industry. It's really interesting for me because we were working on vision systems in the early 80s. I started when I was a mere child, okay? But my background is I bring technology from the world here. Example, we worked with the Israeli defense industry to bring a vision system to Levi Strauss that changed how denim was inspected and how cloth was cut for jeans in the 80s. How many in the room remember the company RCA? Okay, we worked with RCA and the Belgium government there was a company, Barco, they came up with this great acronym, Belgium American Radio Company. We were collecting big data in the mid-'80s in the textile industry, okay? So that's my background. How did I get to here? How I got to here is simply by thinking. I started thinking about where is this whole subject of all of this IoT, Industry 4.0, augmented reality, virtual reality. Where is all this stuff going, and how is it going to get down here to where we are, okay? So I'm the self-appointed person that's on that mission. So I started looking around, and as the name says, CDOT, and our belief is, and our vision is, that we as people, as workers in industry, need to and will get to where we can see the data, okay? And we're going to take a journey on that to get to that. But to get there, as the title of my talk, so to say, says, is we have to start with reality. If we don't know where we are and we don't know what is reality, we sure as heck can't get to augmented reality, and we can't get to mixed reality, and we can't get to utopia. So I partnered up with a company in Germany that came, well, if you'll, Noel's my clicker over there, and one of our engineers. So we're located in Duncan. I'll give 2 shout outs to our company. We've got a worldwide group, and then we are an SCRA SC client company. So we're proud to be working with SCRA. And to your question about how do we bring industry, academia, and innovators together, we're doing that. We just relocated with Spartanburg Community College at the Spark Center in Duncan. So we are collaborating with industry, ourselves, institutes in Germany, and Spartanburg Community College, and I'll show you some things we're working on in that. So that's how I think we bring it together. Okay, we got to get the engagement. So these are the guys in Germany. They came out of the DFKI, which is the Institute for Artificial Intelligence in Kaiserslautern. They did the research there, spun out the company IOXP, which means input-output of experience, and moved down to Mannheim. So what do? We start with reality. We capture by utilizing any kind of video device, a mobile phone. Everything you'll see today is done with an iPhone 6. The camera on a FirePad, the camera on an iPad, the camera on a Surface, it doesn't matter to us. So we see what a person is doing, not what management thinks they're doing, not what engineering planned for them to do, what they are doing, okay? And when we're going through this, I'm also not a professor, so I live in the world of interruption. So if you want to ask a question, just shout out, okay? Or if you want me to repeat something. So we take the image, we put it into our software. Our software breaks that down frame by frame into what that person's done, and then we go in and do post-processing and can put in all kind of animations and safety and so forth and so on. How does it differ from video? Okay, you take a video of somebody doing something. If that process changes in the next minute, what you did is trash, right? Okay? Another thing, I'll challenge you and we'll show you, we did it over here at the Innovation Center with Grable Tech with Haas Machine Company. Go on YouTube and try to watch anybody that says they can watch a 2-minute and 34-second video without missing stuff, without getting too bored or whatever. It is not reality, okay? So we can take what we video and we put it into our system, and you get an interactive experience with that same content in about 40 to 45% of the time, okay? Time of your time consumed in order to get up to speed. We put it on a platform that's interactive where you can go back and forth, and we'll show you those things. Oh. Okay, so we do into three things. Reality side, and we create these that you'll see, and we'll show you examples of that. Augmented reality, and I hope you had a chance to see Noel do it in the back corner back here. If not, after everybody's talked, he'll be set up and can show you the augmented reality side back there. The mixed reality, which we assign that word, and Microsoft has to their HoloLens platform. And the fourth thing is, where are we going? And before we finish today, I'll tell you where I think we're going. okay, and where we can get to relatively quickly. All right? So this is an example that we did in the healthcare industry. So if you apply this to manufacturing industry, wouldn't you like for the workers in the factory to take the same care with the process, the same care with creating the product, the same care with your customers as you want in a hospital? Okay, I think most people would say, yeah, right? Okay, so what we did is we took, this was 52 seconds of video of how a nurse or a nurse practitioner should operate an Alaris IV machine to make sure when you're laying there in the bed, you're getting the right medicine at the right dosage. And believe me when I tell you this, in the right measurement. It's a huge problem in hospitals, okay? And it's a huge problem in the nursing industry and also in industry of skill decline. Because when the nurses are rotating, this nurse example, the nurses are rotating around, some of them may not have done things that they know, okay? So they may make errors, and we help them prevent from making the error. So the person can look at this and learn it in a conference room, at their home on a mobile phone, on a tablet, on a computer, on smart glasses, however they would prefer to consume the data and the information they can. So you can see, I guess you're clicking through right now?
Yeah.
So this is showing step by step. So with somebody learning or somebody refreshing themselves, they can click as fast or as slow as they want, okay? From step to step. They can also see in the top left, it's a little bit funny on these big screens. In the center, they can see what they're doing. In the top left, they can see what they did. In the top right, they can see what they're going to do. So in one view, they can see three things in their minds. Okay? Make sense? Okay? So that continues on. And then this is where we do the work. So to say on the program, when we put the information in, it goes across all of our platforms automatically. So we're working in this view, and this is creating old-timey process engineering flow diagram, right? So if we're doing this, and now convert it over to an industry example. Say this was our process to make widget A, and we had one quirky customer that wanted us to, after the third step, do something special. We can program that in. When that order comes in, hit deploy and send it out to the manufacturing floor to help the workers perform the job correctly. If it's a process where there's a yes or no, or there's a this or a that, we can put those questions in at any point, that if this is coming down the process and it's blue, you do this. If it's red, you do this. If it's this, you go to step 3. If it's this, you go to there. All of that's possible in our system. Simultaneously, we create for other views or also for ISO certification or ISO audits, printable documents. And this is the exact same thing, it's just in a printable form. It can also be viewed on a screen, so if you have a person that is easier for them to learn, going up and down, they can do it this way, okay? Because I believe, and what all of our discussions are about, is it's very simple. Everything has gotten and will get more sophisticated and more complicated in industry. So we, let's say as management and innovators, are asking the people that, I hate to say it about humanity, but more or less or less qualified, to know more things, to do more things. If we as management don't give them the opportunity not to be trained, but to learn, if we give them the opportunity to learn how to do what they're requested to do, they're going to be a whole lot happier, a whole lot more productive, and produce a whole lot better quality. This is the example from Greenville Tech's Innovation Center on the Haas machine. So it's a typical 2-minute and 34-second video of their expert telling you about how to change this turret on this machine, okay? So like most experts, they know subconsciously what tools they're gonna need and what's gonna happen. So they don't tell you up front, and the expert always knows it so much that at the end of the video, he or she repeats what you should have listened to when your mind drifted in that 2 minutes and 34 seconds, which everybody's mind drifts. There's no question about it, okay? So we took their video, converted it over into our system, and we can move the already existing film around because we're working frame by frame. So we put up front, what the heck is the thing you're working on, okay, to show them what it is. Next, we show them what the tools they're gonna need to work on it. And so now they can click through, and you see this is about 10 steps, right? So the other thing, when you're sitting there watching a 2 minute and 35-second video, you're thinking, subconsciously, all of us are thinking, how much information have I got to remember? How much have I got to consume? What's gonna happen next? Here, you see it. Oh, there's 8 steps to it. And you can click back and forth from step to step and in between the steps, etc. And this is an example of the yes/no that you can insert. Yes, if you go to more steps. No, you go to another step. Any questions about that? That's what, yep.
So how do you do the post-processing? Is it done manually?
Yep, on the software. Yep. So we call that the authoring station, where you're manipulating the software. No IT people involved. It's if you know a little bit about files and you can copy and paste and drag and drop. That's it. Yep. Noel, who's a mechanical engineer, interfaced with our German colleagues 2 one-hour Skype sessions and did this. Now, so it's relatively easy. Hey, now I have a question. That's the reality side of our business, okay? So moving to the augmented reality side. How many people in here have ever put smart glasses on? Okay? How many of those people have had them on for more duration of time other than to say, man, this is cool? A few, couple. All right. HoloLens. How many people have had them on their head? How many of those people longer to say, man, this is cool? Less than, the numbers are going down, right? Okay. Virtual reality. A few gamers in the audience, okay? All right. This is my belief about all of those subjects, okay? The contact lens business in the world is a $14 billion industry. The LASIK surgery business in the world is about a $4 billion industry. If human beings wanted to wear glasses and goggles, those industries would not be that large. Okay? So now think about it. We as management have this great vision of all this AR, VR, MR. And we're going to ask people that have spent collectively $18 billion not to put these things on to start putting them on. Okay? That's what we're doing. Now, applaud all the smart glass manufacturers, the HoloLens people and the VR people. They are taking us a step on the journey. We've left reality, we've moved to these AR, MR things, and they're taking us on a step to where I think we're going, okay? So now, with AR, this is a few examples of AR we're doing. What Noel was doing back there, so it's training, helping people learn. It's also can be used in a form of controlling quality, if you will, because we can see when somebody does something incorrectly, and we can send a signal, example to a Siemens PL7 controller or whatever, and say, hey, this has not been done correctly, stop the process. So AR can be used in a few different ways and displayed in a few different ways, as you see. We can show it on a tablet, we can show it on smart glasses, we can show it on a phone, multiple ways to deliver the information. Another part of AR for us is optic recognition. And that's what he's seeing on the bottom, on a Microsoft Surface. He's holding that surface up with the camera on. and it's optically recognizing what it's looking at, and it's bringing up information about that part. This I know happens to be a maintenance application. So it's bringing up, what do I do for maintenance, okay? So we're delivering that type of AR. It's a bigger subject than just smart glasses, okay? Now, we'll go to Clemson. This is at the Innovation Center, one building over. We did this work with BMW, and over there they have what they call a VAC, Vehicle Assembly Center, okay? So this is our phone app. You can take our phone over there with the app on it, turn it on, it'll recognize the control panel. It tells you that, in this case, we've got it programmed to be at ICAR, right? So to give Clemson another shout out, we've got it programmed, it shows that we're at Clemson, and then you can toggle through on the phone step by step, exactly like Noel was showing you on that Alaris pump. You can do that step by step. So imagine for industry, again, helping the workforce do a better job. Annual PM, those that are in industry in here, probably unlike in the past when the person that's doing the annual PM, or unfortunately now sometimes quarterly PM, the person that did it last year, they're not here anymore. They've moved on, okay? So now we've got to get somebody educated, etc. Nobody's going to read the book. Nobody's going to have the knowledge. So we can put that on a mobile device where if they're up on the roof working on the HVAC unit, they can optically recognize it, and it brings up the instructions of what to do step by step. Another delivery form of AR, okay? These are examples of HoloLens. Okay, for those that have never used smart glasses, when you put them on, it's a little bit crazy for your brain, okay? What you're seeing and what all you can do with it, all right? The first 10 times you put on HoloLens, it's crazy for your brain. What you're seeing and what you're doing, okay? The difference in mixed reality is, first of all, back to augmented reality. Just for those that might not know, augmented reality, we're still in this room. We're still in the world we're in, and we're seeing everything just like without the glasses on. We're just putting things in our field of vision, okay? With the HoloLens, it's the same way. You're still in the room, okay? You can still see everything. But with it, you can leave things, okay? So if you're putting a machine in a plant, the technician that's putting it in can leave photos, can leave messages, can leave videos, etc. You can call up the internet, okay? And whatever that person leaves there, you can go back in a day, a week, a month, 10 years, put on HoloLens and see everything he or she left, okay? So it's a fabulous tool, okay? Is it something that somebody's gonna wear on the head all day? Absolutely not, okay? All right. You know, Microsoft, this is still the first edition. The second edition depends on who you're talking, what rumor you're listening to, but maybe Q1 and probably Q2, they're going to come out with the second edition of it. It's going to be, I'm expecting it to be really good, okay? So it's something to really keep your eyes on. There's another thing to really keep your eyes on. If you haven't looked at this company, Google them because it's really fantastic. But I'll tell you, it's been next week for about 3 years, okay? They just shipped developer kits 2 weeks ago. It's a company in Florida called Magic Leap, like magic trick, and leap like jumping off of a building. If it happens what they say they are planning, it's a game changer. It's still wearing glasses, okay, but it's something beyond HoloLens in its current edition, all right? So it's really clever. It's this far beyond. Magic Leap has had a capital investment from investors, $2.3 billion to make it happen, okay? So there's some big bets on that, right? So it's something to have a look at. All right. Everybody understand that? And with HoloLens, you can walk around the things like that. It's a great thing for medical, like that heart, you can walk around it. It's, again, how are we gonna change education with such things as this, okay? I'm not gonna talk about that quite yet, I'm gonna say one more thing. On that journey of the headwear, okay? It's coming, and thank goodness it is. Apple just bought a company 2 days ago with the lens part of that subject. They paid, everybody's saying somewhere 50 to 100 million bucks, okay? The entrepreneur's dream, right? So Apple's betting big on it. Microsoft's betting big on it. Intel's betting big on it. Magic Leap's betting big on it. It's a lot of money chasing it, okay? And as always, the hardware is chasing the software. The software, you know, we've got software running on it, okay? So it's no problem on the software side. It's how to deliver it back to human beings in a useful way, and a way that they'll interact with it, okay? There's so many, I can tell y'all, believe me, there's a lot of cardboard boxes with dust on them with Google Glass. There's getting a lot of boxes around with HoloLens in them and dust in them. And people say, yeah, we got some of those things here somewhere here, okay? Because it's a developing thing. Intel, I was telling somebody this earlier today, Intel bought a smart glass company, $25–30 million. They had it 3 months and shut it down because they realized they were going to have to spend another 40 to chase it, to chase the market. So that's really changing very quickly, and it goes back to our philosophy. Our philosophy is that, hey, let's start with putting the subject of AR on smartphones, what people are used to using, on tablets, what people are used to using. Everybody likes to give Amazon a shout out on Fire, what do you call it? Fire Stick or something, Fire Pad, whatever it is. Okay, so we believe it's those kind of delivery methods where the information will be consumed. But it'll come, the hardware will come. Why the heck are we spending all this money, all this time, all this energy on this? It's to this, okay? What we want to do is we want to get our fellow human beings to learn at a faster rate in a way that they can consume the information. And if you want to say to the millennials or the next generation or whatever it is, okay, we've got to put it on a platform that they're going to accept using. And at the moment, that platform is smartphones and tablets. If you want to put it in a big owner's manual, God bless you for it, but nobody's going to consume it. If you want to put it on the 10-minute company video of, welcome to our company, we're glad you chose us, forget it. It might make you feel good, but it's not going to help you much at all going forward. Because you're relatively young, even though you do have a beard. Are you going to sit and watch a 4-minute video of somebody saying, welcome to our company, we're glad you chose us, we're safety conscious, blah, 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 blah. It ain't happening, is it? But if you can interact with it and get that same information in about 40% of the time, you're going to do it and you're probably going to remember it. And that's where we see innovation, industry, and academia, the crossroads that you were talking about, coming together, okay? But it's going to take a joint effort in it. And it's going to take, there's a difference, okay? Everybody talks, a lot of people talks about the early adopters, okay? Thank the Lord for the early adopters. We need them, okay? But what we need more are the visionaries. The difference is this. The early adopters like cool. Man, they like cool. That's the guys and girls that are lined up at Apple on the day they got a release. No matter if it's different or anything, they line it up, okay? It's cool. The visionaries are the ones that knows it's cool, but has a plan of execution, okay? And I'll give you an example. We're working with a major company right now. They said, okay, let's get started. Waiting on the check to clear, okay, but let's get started, all right? And they said, now, the next thing is, let's go ahead and organize a monthly follow-up interaction meeting with all parties to make sure it doesn't get put in the cardboard box, that it doesn't get misused, that somebody doesn't understand, that somebody doesn't get frustrated. Those are the visionary people, and that's the people that will move all of these subjects forward, okay? So that's another one of my intersections, so to say. All right? So, first thing, we want to compress time and comprehension and learning, the top left. The next thing, and this is really key, there's two things I learned from my career in industry. Nobody likes to tell how much obsolete inventory they have. Nobody likes it. Everybody's got it, okay? The second thing, nobody likes to talk about how much cost is associated with turnover, okay? And the most costly part of turnover is this little bitty black line up there on the top right graph. That's the person that took the job, they took all the time for interviewing, they took all the time with the HR department, they got the job, got out there and said, man, this isn't what I thought I was going to be doing. And 2 weeks later, they're gone. The most costly turnover, okay? Because we now lost everything with no return. All right, so we would prefer for those people to understand the job. Now with our system, they can look at the AR, they can sit there and click on the reality side, and they can see exactly what the job is before they take it, okay? It's very, very, very costly for industry. The bottom two are kind of hand in hand, the skill decline and preventive maintenance. What we can do by showing the people, like the phone app that I was showing you, where you can click through as you're up on the roof, you would expect the person to do a fairly consistent job if they've got the information right in front of them, rather than somebody that might remember, might not remember, might remember, might not remember, okay? So we're talking to a major international company right now about that, and where they can have people all over the world, because they've standardized their equipment and some pieces of their equipment, and they can have then everybody all over the world operating off the same platform, performing the same steps, and learning the same nomenclature is a big part of it also. Because the other vertical we're working in is with machinery companies, and somebody was talking about robotics earlier, one of the robotics companies, and they can't hire, you have to think about it from the industry side, okay? That machinery company, they've got to hire somebody, train them to be an expert, to train your person to be an expert, to train the workers to be an expert, with nobody leaving the workforce. It's almost impossible today, okay? So that's another thing that we're seeing on this, all right?
Philip, a question. for
Yep.
you. You mentioned companies standardizing all over the world and they do these things.
Mhm.
How do you handle local language?
We can put different languages in here, but as you see, and we can also put audio over it, but as you can see, most of what we're doing is visual, and people are learning more visually now. So it's really a visual thing to see it. But we can annotate it with different
So
languages.
video with, arrows and things of that nature.
Mm-hmm, mm-hmm. Yep,
I guess the Europeans love to do that on you try to assemble a piece of furniture and you get a piece of paper with all kinds of symbols so that there's no language at all.
right.
Where it just makes it,
Yep, yep. So that's kind of what we see in the universal. And it's really funny. Another trend, we're seeing a couple of other trends. One trend is not not wanting audio. First time I heard it, I thought, well, I wonder why. And then we started hearing why. It's that you depend on it, and then you do it, you're playing the media over something that's got a broken speaker, or the volume doesn't work, or the volume's wide open, or there's a bunch of noise. So we're seeing a trend to not have audio, to have it visual and have it words. Because as you see, what we're doing is very concise, okay? When we take a video clip, we cut out normally 50 to 60% of it. We only use just what you see, what you need to see. Okay? Yep.
Are you building in there any sort of recognition whether people are actually tracking or not and being able to confirm that? So, for instance, my tablet here, my identification is I just look at the thing and it recognizes my eyes and then says, okay, you don't have your password, it just goes in. Do you have those sort of things built in, or can you see potential for building that in? So then you can confirm as an employer, let's say, yes, in fact, this person not only took this course, but they paid attention to this part. Or, oh, they forgot to pay attention to that part, you're gonna go back and take some more.
Yeah. The short answer is yes. And we get asked that a lot because, everybody likes to skip to the end, right?
Yeah.
Has its advantages, okay? But we also are getting people to understand it also has a disadvantage, all right? Because what we prefer and what we have seen people do a better job of learning is when they can go back and forth. You're still gonna have the individual that cheats, for every system built, there's 10 people learning how to cheat it, right? But we see that giving the people the opportunity to go back and forth is better than the rigidity of do this, do this, do this, you can't go back. And we're clocking you. Because we as management, I think, have finally come to the realization, it doesn't matter if I have to look at it 4 times and you can get it the first time. As long as I get it, it's okay for me to take 4 times, okay? What we've also encountered is, there's obviously still a lot of OJT going on, right? And what we've also encountered is by giving people access to this and letting them go through the job before they go out for OJT, on-job training, is that their reception out on the production floor is much higher when they go out there with a higher level of understanding of what they're being asked to do. Okay? Yep.
So how do you use the hands-free? So if the task needs both hands, so and you still need one hand to hold the cell phone, right?
Yeah. Being on a mobile phone is just one delivery device. We can also have it on a fixed display like Noah has set up back there. You can also have it on smart glasses. So those are the other delivery methods to free the hands up.
So I'm going to ask the next question and ask him to ask over here on this table.
Okay.
They were going to ask you.
Yeah.
Okay, the back there.
I do have a question. You showed us the examples for the education purpose, like everyday entertainment. For those things, mostly they are for consumer grade, and we know that consumer could be very picky. And I'm from Clemson University. We do things cheap and dirty at labs. So what can we do at universities to serve the very picky consumer world for the AR?
On the consumer side,
Yeah.
did I understand you right?
Well, I was just saying that I'm from the academia.
Right.
And the AR, from your examples, and mostly the AR being used in the consumer product market. So what can we do, or do any research on this to deploy our product directly to the consumer grade, or can we do anything for other purposes such as like industry engineering?
Yeah, if I understood your question right, we're not working with consumers at all. Okay, we have zero interest in working with consumers. All right? We're working strictly with industry. And then also for academia, one of the challenges that we've been asked there and has come to our attention is that and I have a sister that's a professor, and she says, and also I've heard this at multiple academic institutions, when they're searching for people to do the teaching, okay, how do you get the teachers, the instructors, the professors, whatever level you want to call them, to deliver the instructional material consistently across 8 campuses, or sometimes even on one campus, okay? Because everybody's going to interpret it different. But when it's a procedural thing, and you saw our example in nursing, and the reason we're working in healthcare is, I think all of us would agree that we would like for nurses to understand procedures and do them correctly each time and consistently. Yes, there's some instructor or professor spin of experience that can go around it, but when you're talking about a methodical, step-by-step procedure, we want them doing it the same every time. And I can tell you who really wants that is the risk manager at the hospital. He or she really wants it done the same every time, right? And the patients, of course.
So actually, to qualify that question perhaps a little bit and add to that, what are the missing gaps in what you're hearing from your consumers that might need more research? Because the perspective that some of the students and potentially the faculty are bringing is, this is a great product. It's like an iPhone that you buy off the shelf. And it does wonderful things. But what's missing that you're hearing in your conversations with your...
The data behind it. And it's now I have to understand your question again. The data behind it. And it's a project that I think we'll know next week that we're embarking on healthcare is the data analysis of students and instructors and their performance when using such tools.
So if I did step 3 wrong, or multiple people did step 3 wrong 90% of the time, it could be a process issue or a machine design issue or whatever. Is that
Right.
what you mean?
That's right. That's right.
So that's one, but it's also, I think he's saying, training perspective. What are the numbers of steps you need to break it down into? What is the rate of skill acquisition? Does this modality supplant active engagement in a face-to-face setting? That research is missing.
That's right, exactly right. And another thing for the academia people in the room that we're listening very attentively to is the rebirth of industrial engineering concepts. And it's not the engineering schools that are talking about it, it's the business schools that are talking about it, okay? Because in industry today, general statement, okay? In industry today, that analysis of process and process control is not what management thinks it is, and certainly not what it should be, okay? So what we're also seeing a need for academia side brought into the picture, again, the crossroads that this gentleman was talking about, is that manufacturing, and I love manufacturing. Manufacturing, you know, when we go into a plant, their job is to make the product, right? They got to get the product out the door, all right? So they don't have the staff anymore because of downsizing and making it lean and cutting costs and all of that stuff to do those things. So coming back to academic interface and research, I think that's a great area of collaboration, is to go in and do those statistical studies and analysis of what is the process, how can the processes be improved, and what are the results from the changes that we've done. Both on the process side and the human side, because the process doesn't work without the humans. It's refreshing. I used to be in the human elimination business through automation, okay? Now we're in the human helping business by helping people to learn and helping companies help the people learn. So
One last question here.
Yep.
And we're gonna have to move on.
So it seems like you were talking about the learning process, so it seems like it's static. Have you ever looked at, since we're talking about AI, using machine learning to actually personalize the learning experience for each person? Because it seems like, you know, people learn different ways. I may learn a different way from you.
Yeah.
So actually using machine learning and artificial intelligence to figure out ways in which you should deliver the information to where it's dynamic to each person.
Yeah, but it's a big challenge. Big challenge, right? But let me, I'll answer that this way, Jerome, in my last statement, because I left this out. Where are we going, right? I said it earlier, where are we going? This is where I believe we're going, and it's not in the too distant future. We will be able to walk up to that Alaris pump, we'll be able to walk up to this machine, whatever it is, not to ask how many monks are in Tibet, okay? We don't care about that. What we care about is what are we looking at and how can we make a better product, improve the process, etc. We will be able to walk up there and we will be able to say, I need to see the instructions of how to do this process. And it will appear. It will be there. We won't need a big monitor. We won't need smart glasses. It will appear, okay? Don't ask me how. If I knew the how, this room would be out the doors bursting to hear me talk about it. But we're gonna get there. We're in discussions now with another technology company about hyper eye tracking and the things that are going on with people throwing 3.2 billion at Magic Leap, 100 million for this, 50 million for that, 200 million for this. It's gonna get there. That's where we're gonna get to. That you'll be able to set up your factory, you'll walk in, the person will need assistance, and because we put the information there somehow, they're gonna be able to ask for it and go back to our name. I'll leave on this note, seeing the data. CDOT is our name, and that's what that means, seeing the data, the information. We'll get there.
Great.
Okay, thank you.
So I'm going to take privilege here to take 5 minutes for folks, because there's all kinds of people walking in the background. I understand that actually getting to the restroom here means you have to walk across the stage. So why don't we all just take 5 minutes, if you don't mind.